Welcome to the underwater world. Rocky Mountain Aquatics invites you to this presentation on how to use dive tables. The air we breathe is composed of nitrogen and oxygen. We use the oxygen, and under pressure we store the nitrogen. So the nitrogen we are breathing underwater becomes stored in every cell of the body, creating millions of tiny 7-Up bottles. What would happen if you shook a 7-Up bottle? Bubbles would form. If you dive too long, go too deep, or come up too quickly, the same effect will happen in the human body and could cause serious damage, pain, and even death. Dive tables track the amount of nitrogen stored in our bodies and help us to determine how long to dive, how deep to dive, and how long to stay out of the water before we dive again. Dive tables come in various forms and sizes and shapes. This is a common plastic version. At first glance, it looks rather intimidating. There's a lot of numbers there. Before you go any further, you should have the study guide. Turn to page 12. This is the first dive table problem in the study guide. And we will review this problem, and then you should be able to do all the rest of the problems in the study guide. If you do all the problems in the study guide and check your answers against the answers in the study guide, you should have no problems in taking the final exam. The first dive has you diving to a depth of 60 feet with an actual bottom time of 40 minutes. RNT is your residual nitrogen time. And since you don't have any, because that is a measure of nitrogen stored from a previous dive, that is 0. Your total bottom time is obtained by adding 40 and 0 together. And I know this may be tough at times, but adding 40 and 0 should equal 40. This is the dive table in your study guide. Actually, there are 3 tables on this one sheet. Table number 1, table number 2, and table number 3. We will look at each one of them separately. Table number 1 tells us how much nitrogen we have absorbed as a result of diving at a certain depth for a certain length of time. The first column is depth. The second column is our safe limit at this depth. The third column is the safe maximum limit at that depth. So since in our previous dive we went to a depth of 60 feet, we go over to the right until we find a time of 40 minutes and come straight up and we find the letter G. That G is a symbol for the amount of nitrogen stored in our body at the end of that dive. At this point, this is what the dive table problem should look like. Residual nitrogen time of 0, total bottom time, those two figures added together, 40 plus 0, or 40, and our dive group designation, the letter G. So we know that we have a G amount of nitrogen stored in our body at the end of this first dive. There's a number there, 2 hours and 15 minutes. That's our surface interval. We have been out of the water for 2 hours and 15 minutes and want to do another dive. That's when we go to the second part of the dive table. We find the letter G on the diagonal line and go to the right. There are a series of time windows there. There's a time window at the first column that goes from 10 minutes to 40 minutes, the next one from 40 minutes to an hour and 15 minutes, and then the next one from an hour and 16 minutes to an hour and 59 minutes, the next one 2 hours to 2 hours and 58 minutes. our time window falls within that time period. So we'll follow that straight down and we find a new letter, the letter D. Instead of being in category G with that amount of nitrogen, we now have a new letter, which means that we have less nitrogen. We have a D amount of nitrogen stored in our body. We have to look at what that means. The bottom table is our residual nitrogen table, and it will tell us that we have been diving long enough to have accumulated nitrogen. And if we had been diving for 29 minutes, we would have accumulated that amount of nitrogen. Therefore, we have to subtract that from the amount of time we actually can dive. And we do that by using our residual nitrogen table and look at the second step. We enter our residual nitrogen time that we found from the table in the RNT space. We add 40 and 29 together and we get 69. The table has told us is we have the same amount of nitrogen stored in our body as we would have if we'd been diving for 29 minutes. So we're going to go do an additional dive of 40 minutes. As far as we're concerned, we have been diving for a total of 69 minutes. If we go to table 1 and look at a depth of 50 feet, follow across until we get to 69. There isn't a 69, so we have to go to 70. Even if it were 61, we would go to 70. We always round up. And then go straight up from there, and we have a letter I. So we have increased the amount of nitrogen stored in our body. We started out after the first dive with a G amount of nitrogen. After being out of the water, we only had a D amount of nitrogen. Now we've been diving for a while, and we have an I amount of nitrogen. We're slowly accumulating more and more nitrogen. So we complete our work table. We have a residual nitrogen time of 29. By adding 40 and 29 together, we have a total bottom time of 69. We've looked at the table and we find that we are a letter F. We have also gone to the table and we found out that if we are a letter F diver and we're going to 40 feet, we have a residual nitrogen time of 61. So we add 61 in the residual nitrogen space, add it to the actual bottom time of 65, and as far as we're concerned, we have been diving for 126 minutes. Just to see what we're looking like in terms of nitrogen absorption, we can go to the table and see that we have been diving at a depth of 40 feet for as far as we're concerned for a time of 126 minutes. Look straight up and we have a letter of K. That's considered saturized. We have absorbed all of the nitrogen that we want to absorb. We should stop diving. 12 hours from then, all the nitrogen that we have absorbed will be gone and we'll be starting all over again. Because we have nitrogen under pressure in our body, we should not board an airplane or drive to a high altitude for at least 12 to 24 hours. 24 hours is currently recommended for flying. The military requires 48 hours. Once we have obtained that amount of time out of the water, all of the absorbed nitrogen in our body will be gone and we'll be starting out fresh. If we're only going to make one dive in a day, we can look at the table. For example, a depth of 40 feet. The old tables say we could stay a maximum of 200 minutes. Currently, it's suggested we don't stay longer than 130 minutes. On our last example, we went to 126, which is just beginning to push it. If we go to a depth of 60 feet, we should only stay there 50 minutes before coming to the surface. Our dive table problem in the study guide should then look like this. On our first dive, we went to a depth of 60 feet with an actual bottom time of 40 minutes. Our residual nitrogen time was 0 because we didn't have a previous dive. And our total or theoretical bottom time, by adding those two together, is 40. We went to the table and we looked at a depth of 60 feet for 40 minutes and we found that we had a G amount of nitrogen stored in our body. We stayed out of the water for 2 hours and 15 minutes and now we only have a D amount of nitrogen stored in our body. Looking at the table again, we found if we're going to a depth of 50 feet, that would mean that we had a residual nitrogen time of 29. It is as if we have been diving for 29 minutes before we start our next dive. We go diving and we have an actual bottom time of 40 minutes. So we add those two together. As far as we are concerned, we've been diving at 50 feet for 69 minutes. We go to the table again and we find that if we've been diving at 50 feet for 69 minutes, we have an I amount of nitrogen stored in our body. We're going to be out of the water for an hour and 30 minutes. So if we go to the table, we find that we now have an F amount of nitrogen stored in our body. And on our last dive, we're going to a depth of 40 feet. The table tells us we have a residual nitrogen time of 61. It is as if we have been diving for 61 minutes before we start our next dive. We're going to go down and spend 65 minutes diving at a depth of 40 feet. So we have to add those two together, and as far as we are concerned, we've been diving at a depth of 40 feet for 126 minutes. As a result of that dive, looking at the table, we now have a K amount of nitrogen stored in our body, and it is time to stop for the day. As a certified open water diver, you are certified to do what is called no decompression diving. This table is a small example of the tables used for people who do decompression diving, where they stay longer than we would or go deeper than we would. For example, if I've been diving to a depth of 70 feet for 70 minutes, I come over to the right and it tells me I'm supposed to wait for 14 minutes at a depth of 10 feet to now allow the nitrogen to slowly disperse itself from my body before I come to the surface. There is a dive table problem like this in your exam, but as a recreational diver, you should not do decompression diving. All of these dive tables assume that we are diving at sea level. At sea level, we have an air pressure of 14.7 pounds per square inch when we come back to the surface that aids in keeping nitrogen under compression in our body. If we are diving at an altitude, there is less air pressure to keep nitrogen in place, therefore more danger of decompression sickness. The high altitude conversion table helps us to account for this. For example, if I'm going to a depth of 50 feet, I go over to the right, and let's say I'm at the crater, which is an altitude of 6,000 feet. I have to pretend that I'm actually diving at 62 feet, which certainly limits the amount of time that I can spend at that depth. We hope this helps you understand the process of using dive tables to safely determine how deep and how long you can be underwater. Computers are also very helpful, but if you become completely dependent on a computer and don't know how to do dive tables yourself, you may find yourself in trouble if your computer should fail, leak, or run low on battery power. Work the dive table problems in your study guide. If you have any questions or need to go through them again or need to discuss them, please feel free to request that from us. We'll be glad to do that. Enjoy diving.